Hello everyone, welcome to Complex Engineering. In this video I am going to talk about technical parameters of pantograph. Technical parameters we can also call it as technical characteristics of pantograph. Like what is the nominal voltage of which pantograph is going to work and what is the maximum extension when MED is operating, right? So let's get started with the first parameter, first technical characteristic, nominal voltage for which pantograph has been designed is of 25 kV kilovolt alternating current. This pantograph is not going to work with the DC system. That's the reason it has been written over here 25 kV AC. Now the maximum extension. What is the maximum extension? As we have already spoken in one of the video, like if pantograph is going, if our train is going out of the OHE zone, then MED will operate, maximum extension device will operate. MED device also known as ORD, overreach detection device. So in this way what will happen, ORD will operate, and due to which the pantograph will come down to its lower position due to the gravitational force, and it is known as abnormal lowering. So the maximum extension of the pantograph height is of 1720 mm. Plus minus variation is acceptable, plus minus we can say it is the variation in 1720 mm. So we can say 1720 mm is the maximum extension of the pantograph. Now the carbon strip material which has been used for designing the carbon strip is metallized carbon. So not only the carbon has metal part as well. That's the reason it has been written over here metallized carbon, right? And then length of contact strip, very important, length of contact strip. What is this term is indicating? Trying to convey length of contact strip. See, in our one carbon strip there are two end horns, right? So from one end horn to another end horn, the entire length is 1240 mm, 1240 mm. So if entire length of the pantograph pan head, specifically talking about carbon strip, in simple term we can say the entire length of the carbon strip along with the panto end horn is 1240 mm, right? I can also say like the entire length of the pantograph head is 1240 mm. So if entire length is 1240 mm, then half of the length will be somewhere around 620 mm, right? So it is one of the important thing that we need to consider, like entire length of the pan head is 1240 mm. And then here pan head profile height of the pan head, right? So what is the height of the pan head, right? Height of the pan head is 162 mm. So these both are the important data, technical data I have encountered in this situation. Like many people are asking me what is the entire length of the pan head. So that's the reason it is very important to answer them for me, and I guess it would be for you as well if you are working with the rolling stock industry. Then 1240 mm is the entire length of the pan head and 162 mm is the height of the pan head, right? Now we can skip rest of the parameters because there are many technical details. If you are remembering all these details which is not important, then it is not worth. So that's the reason I am skipping the details, technical details which is not in the requirement, right? Working range and then total length in the rest position not require. Electrical clearance 290 mm, greater than 290 mm. It is, this point is also important, greater than 290 mm. The electrical clearance, in the electrical clearance, first of all we are talking about electrical clearance about which equipment. Here which equipment which we are considering, and electrical clearance of which equipment are we talking about? Here we are talking about each and every electrical equipment of roof. Like we have potential transformer, we have current transformer, we have like pantograph, we have surge arresters. So the electrical clearance should be greater than 290 mm of high voltage equipment. In simple term I can say like that, in high voltage equipment, the electrical clearance should be greater than 290 mm. In between high voltage equipment, electrical clearance should be more than 290 mm, right? Now here what is written, overreach detection device or automatic drop down device indication. Yes, we can if ORD device, as I have said, ORD also known as MED, right? And ADD, automatic drop down device. So if this protective device is operating, then we'll get to know about it with the help of the indication system, right? So that's what here it has been written. Overreach detection device or automatic drop down device indication. Is this feature available? Yes, that's written here. Yes is written, right? So number of insulators, one of the important question which comes often. Number of insulators, how many insulators has been given? Insulator, first of all, where is the location of the insulator? Insulator is located at the downside of base frame assembly, right? And number of location which is there, number of insulators which is there in our drain is 3. Now maximum current is 250 ampere. Maximum current in running condition is 250 ampere. It is also one of the important question, maximum current at running condition. How much current, how much maximum current drawn by the pantograph when the train is in the running condition is 250 ampere. So 250 ampere is the maximum current when the train is in the running condition, right? One of the important technical question. And static contact force, about which already we have discussed, is 70 Newton plus minus 10 Newton, like it is the variation. So static contact force about which we spoke in my last video is 70 Newton. Static friction, it is very important to break in order to raise the pantograph from lower position to the upper position, and in order to break down the static friction there is a requirement of static contact force which is of 7 Newton for our design of pantograph. However, this magnitude of force is not fixed for all the pantographs and for all the trains in the universe. For our train and for our design of pantograph, this 70 Newton force is applicable to break the static friction and to maintain the static contact force. Now what is the static contact force? Static contact force is the continuous force which is required to keep the OHA and contact wire in contact with each other. So that is known as static contact force, right? Now maximum speed for which this pantograph has been designed is 95 km per hour. So maximum speed for which pantograph has been designed is 95 km per hour, right? Operating temperature range is minus 25 degrees Celsius to 70 degrees Celsius. Minimal pressure in input 5 bar, maximum pressure in input is 10 bar. So we can say input pressure in pantograph. We have like panto control circuit, about which I am going to discuss in a detailed manner in my upcoming videos, right? So in panto control circuit there is incoming pressure, and panto control circuit like modifying that pressure and it is transmitting that pressure to our pantograph, due to which pantograph is raising from lower position to the upper position, right? So that's what here it is written. Minimal pressure in input is 5 bar and the maximum pressure in input is 10 bar. Here what input we are talking about, which input here we are specifically talking about? Here the input of the panto control circuit. Let me show you the panto control circuit, pneumatic control circuit. Panto control circuit, also known as pneumatic control circuit. This how pneumatic control circuit looks like. In pneumatic control circuit we will get like different switches. This is the pressure switch 1, this is the pressure switch 2, and this is the pressure reducing valve. This valve is known as pressure reducing valve. And then we have like filters, solenoid valve. What are the function of all this component which has been integrated in pneumatic control circuit? We will have a discussion over this topic. And then we have on delay timer for ADD indication, which is located over here. And then we have PLV1 safety valve, and then outgoing air to pantograph, incoming air from ORD, and then incoming air from ODD device, and then filter, and then pressure switch. So what is the requirement of using all this component? We are going to discuss about it in my upcoming videos. But for the sake of simplicity, I was showing you the panto control circuit, which looks like this peak. Okay, this is the peak of the panto control circuit. Okay, so the input pressure which is coming in this panto control circuit is from 5 bar to 10 bar, right? Minimum pressure is 5 bar and the maximum pressure is the 10 bar, right? So the pressure which is coming in our panto control circuit, its minimum value is 5 bar and the maximum value is 10 bar. Now maximum lowering time and the raising time of the pantograph is 10 seconds. So maximum lowering time is 10 seconds and maximum lowering time is 10 seconds and maximum raising time is 10 seconds. So the time which is required by the pantograph for raising and lowering is somewhere about 10 seconds, right? Now weight of the pantograph with the insulators 131.96 kilogram, weight of the pantograph without insulators 107.36 kilogram. Again, these technical features, technical characteristics are important according to design perspectives. Now color of the pantograph is gray. Now color of the pantograph is gray. In one of my video I have shown each and every component of high voltage system practically, in which we have seen like upper arm and the lower arm, and then the base frame assembly were painted in the gray color. So that's what here it has been written, color of the pantograph is gray. Now mechanical clearance from the fixed structures. Now how much is the mechanical clearance is 100 mm. So this technical data is also important. How much is the mechanical clearance? Like 100 mm. So in pantograph strip, it has been observed often frequently, like a groove is forming over the carbon strip, and the main cause of the groove was the improper stagger calculation. So whenever we are doing analysis like of the groove and what is the causes of the groove, we are considering all these technical parameters, like how much is the mechanical clearance, how much is the like length of the pantograph, length of the pan head, which we discussed, it was somewhere around 1240 mm, right, and half of the length was 620 mm. So these technical characteristics, technical parameters are also important in order to do the analysis in case of uneven scenarios, or can say in case of maintenance.